Lesson 114, the exponential key. There comes a point in algebra when you really just need to use a calculator. And one of those points is the exponential key. And what that's going to do for you is solve problems that have big exponents. Like for instance, if we had 1.06, I'm going to write that down. If we had 1.06 to the 8th, I really would not want to have to do that multiplication, 1.06 times 1.06 8 times, right? So we can instead use a calculator for that. And in order to do that, what we're going to do is we're going to type in, we're going to first identify our exponential key. And on my computer, it tells me that it's XY. I'm just using the calculator that's built into my computer. Okay, so what I'm going to do is I'm going to type in 1.06 and then I'm going to raise it to an exponent of 8. I'm going to do it like this. 1.06 and then I'm going to hit the exponent key, which is XY. And then I'm going to type in my exponent, which is 8. And then I'm going to hit equals. And apparently I didn't do something right. Let me clear it. 1.06 XY 8 equals. There we go. I just must have not hit something all the way. And so this is your answer. It will tell you what 1.06 times itself 8 times is, and you do not have to do it all on paper or in your head or by hand, or even 1.06 on a calculator 8 times. This is so much faster. This is the beauty of having a scientific calculator when you get into that higher math. And this is actually in the book telling us to use a scientific calculator with the exponential key in it so that you can save time in your calculations. All right, now that we have talked about the exponential key, we're going to talk about exponential growth. And exponential growth is a situation where something grows at a certain rate over a period of time. So for instance, Jimmy had, this is example 114b, this is the second part. Jimmy had 150 rabbits, okay? He had 150, that's a bunch of stinking rabbits. If the number of rabbits doubled every year, so times 2 every year, he would have 300 rabbits at the end of 1 year, 600 at the end of 2, and so forth. We use this symbol here, the rate times 0, to indicate the number of rabbits in the very beginning. Okay, so the number of rabbits in the very beginning would be 150. All right, so RO equals 150. We use R1 to represent the number of rabbits at the end of the first year. So that would be 150 times 2. And R2 would be 150 times 2 times 2. You see where we're going? The exponent here, or the subscripted number, is acting like an exponent, telling us how many times to use this rate. So R3 would be 150 times 2 times 2, so 3 2s, right? And that should be 150, sorry. So we could also write it like this, 150 times 2 to the 0, 150 times 2 to the 1, and we know that we usually just don't write that. This is 150 times 2 squared, And this is 150 times 2 cubed, right? And if we wanted to, we could write a formula that says this is the number of years, the time, and 150 equals, or the rate of the time equals 150 times 2t. So whatever this number is here, that will be the exponent here, okay? So we could actually use our scientific calculator. Let's say that it's 10 years. It's year 10. So our formula for the 10th year would be R10, because it's the 10th year, equals 150 times 2 to the 10. So we would pull up our calculator, right? If I can get it to pull up. And we would clear it out. Sorry. And first we would figure out our exponent of 2 to the 10. All right. And then we multiply that times 150. That's how many rabbits we would have in 10 years. That is absolutely nuts. I hope he's giving some of those rabbits away, or he's having rabbits too. Anyway, you see how beneficial it is to have this exponent key to solve this problem. What if this had been, let's clear this, what if this had been 40 years? Let's just change that to a 4. So he's still rabbit farming 40 years later, right? Maybe his kids have taken over the rabbit farm and he hasn't given any of his rabbits away. He's still got them all. How many rabbits would he have? All right, well, we say 2 with the exponent of 40 times the original 150 that he started with. Oh my word. That's a lot of rabbits. But that's a heck of a lot faster than trying to multiply 2 times itself 40 times and then times 150. Right? So much easier. So that's something to think about when you have these exponential growth problems. And that's what this is called. It is an exponential growth problem whenever we have a rate that happens annually. And we have to indicate how many years it is or what the time, or if it happens monthly, it happens once every set period of time. And T represents the period of time that it is occurring. Okay, so in this case, it was years. It could be months, it could be days, it could be weeks. But this number right here is going to be the exponent on your rate. Okay? So this is the starting number, this is the rate, and the year sets the time. This frequency sets the time, okay? All right, so let's move on and look at what we call something that's an exponential equation that we deal with, that you will deal with as you get older, and that is interest on a bank loan or interest on a deposit in the bank. So let's clear this off. Let's say, all right, a bank will pay you to let the bank use your money. Basically, if you put money in your savings account, the bank pays you an interest rate for you to keep it there. The more money you have in a savings account, the more you get paid in interest, but it only happens annually, once a year. And the reason they do that is so that you will trust them with your money. And what they do is they use the money in your savings account to make loans to other people. And then the money that they make off of that loan, the interest that they make, it gets passed on to you as interest in your savings account. Because you have put that money in there and you have left it in there and you have let them use it, and they're, they're just passing on the wealth. So it actually pays to save money. Not a lot. Usually it's around, anywhere from 2 to 4%. It's not a whole lot, but it's better than your money sitting in a mason jar buried in the ground and not growing at all. Okay. So each year, let's say the bank will pay you the percentage of the amount you deposit, or it'll pay you a percentage of the amount you deposit. And the amount that you deposit is called the principal. Principal is the original amount. Okay? It's the original amount that you deposit. It's the original amount that you borrow. Whenever there is something like that going on, the principal is the original amount, or the origination amount. Interest is the rate at which something gets paid. So when you borrow money, you pay interest. So you're paying a bank to let you borrow that money. You're giving them a little bit of extra money on top of that principal that you borrowed. So if you borrow $500, you might pay them back $520. You're paying them $20 interest because you didn't have it all at once and you had to borrow it from them. Okay? Same thing on your savings account. You put the money in, they pay you interest for keeping the money in there. So it's a percentage of the principal. So that's what interest is. It is a percent on the principal. Okay. Let's say if you deposit $100 at 4% annual interest, all right, you deposit $100 and the interest is 4% annually. Okay. At the end of 1 year, the bank will give you back your $100 plus 4% of 100, which is $4. So this equals 1.04% of your original principal, of your original amount. So you would have, at the end of the year, 100 times 1.04. In this case discussed, the interest rate of 4% is compounded annually. This is our rate, so this would be N or T, whatever you would want to call that. We'll call it T because we used T in the original one. That's your time, right? The rate is compounded annually. So this means that the interest payment is made once a year at the end of each year, and that the interest calculation is applied to the total amount, not just to the principal. In general, if a bank pays an interest rate of R, which is a percent expressed as a decimal, in this case, 0.04 is 4%, right? So just so you didn't know, that equals 4%. So this is the original plus 4 more percent. Okay, and this is the original amount. So 100 times 104 is going to be $104. Okay? What this does, we start counting this here at A0. So we're using this format here, AT equals A0, which is the original amount, times 1 plus the rate, and this is the rate. The rate is the decimal for the percent being used. This is the number 1. And then we use whatever this time is as our exponent. Okay? So we see that the equation has the form of, this is y. So it has the form of, as a function, a t, or actually a of t equals a of 0, the beginning amount, times y to the t, right? That's our function. Y is the rate plus the original amount. And the reason we do that is because every year it's not just the original amount that gets the annual interest, it's the total amount. So it's the original amount plus the rate. So at the end of the second year, so the end of the first year you get $104. At the end of the second year, you get, that's times 1.04 again. So let's pull up our calculator. I don't know why I closed that. So at the end of our second year, we have $104 in our account and we get our interest again. So at the end of the second year, we have $108.16. At the end of the third year, $112. Now we only deposited $100, but interest has grown. The end of the fourth year, the end of the fifth year, the end of the sixth year, and so forth and so on. So that's how that works. It is times whatever is in your savings account, even if it's interest that is being accrued. So you only deposited $100 6 years ago, and now it's $126. Okay? That's how that works. Cool, huh? All right, so let's do a problem based on this formula here. So write it down. You're going to need it for the next page for sure. So A of t equals the original amount times 1, or actually we're not going to do this because we don't know what the rate is yet. We don't know what our formula is. So it's y to the t, okay? And y is our variable, our rate. All right, so the number of bacteria in the dish tripled every month. So y is 3. Y equals 3 because it tripled each month. All right, t is the number of months, right? If there were 2,500 bacteria at first, how many bacteria were there in 10 months? So 10 months, so that's a to the 10 equals the original amount, which was 2,500 or 2,500, times 310, because this is t, right? So we need to do this on the calculator. So what we're going to do is pull up our little calculator, and we are going to say, all clear, we're going to say 3 exponent key 10 times 2,500 equals. Yeah, that's a big number. So we're going to write that number down, and we're just going to write, let's see, significant numbers, 1, 4, 7, 6, 2. And then we're going to do some exponents. So let me make a note of what that is. 1, 4, 7, 6, 2, 2, 500. 1, 4, 7, 6, 2, 2, 500. All right, we're going to write that in scientific notation because that would make the most sense. So 1, 2, 3, 4, 5, 6, 7, 8. Ooh, I don't know what that was. 8 places. So 1.4762 times 10 to the 8. Notice how I dropped these off. Okay. These are the most significant numbers that we want. And we usually just use the first 3 or 4 places when we have a long number like this. All right. That's where that would come in handy for scientific notation with a really huge number like that for the bacteria on her, what do you call it, in the dish, the bacteria dish. But that's how you would use this. You would get your exponent, use the exponent key, or you get your rate times your exponent key, and then multiply it times your original amount. And then that's where you would find your answer. And that's so much faster than trying to do it on paper yourself. I mean, really, come on. Who has time for that? I don't have time for that. All right, so let's do another one. Okay, we've got our formula, so we know how to use this. James deposited $500, right, at 7% interest, and it is compounded annually. All right, that's once a year. How much money did he have after 14 years? How much interest did he earn? So we are going to take our formula here. We want to know 14 years, right? What did he have? So A, 14, equals 500 is the original amount, right? The rate, this is interest, so it's compounded annually. Compounded means it's added back to the original amount and all of it's taken into account. So it's going to be 1 plus 7%. So that's going to be 0.07. And that's going to be 14 is the exponent. Okay? All right, so let's pull up our calculator. Let's clear this out. And we are going to say 1.07, the exponent key, 14 equals, times 500 equals $1,289, and we're going to round this up to the ones place for pennies, and 27 cents. Okay? So let me write that here. He has $1,289 and 27 cents after all of that. All right. How much did he, how much interest did he earn? Well, he started off with $500, right? So he earned $789 in interest. So after 14 years of leaving that money in the bank, he more than doubled his money. All right, so you see how you can use this formula. This is the original amount, this is the rate, this is the time, okay? Original amount, rate, time. If you can remember that, let's write that down. All right, this is time, original amount, rate, and then time. Okay, this is this. That's what that means. And when this is compounded annually, right, it means 1 plus, it's not time, sorry, 1 to represent the original amount plus the percent in a decimal. All right. Okay, hopefully you can understand my chicken scratch. But the beautiful thing is you could do this whole entire thing on the calculator and just write down the answer. That's what we were really focusing on in this lesson. All right, so now we're going to start talking about graphing calculators. Our previous section was telling us how to use the scientific calculator, the exponent. So the rest of the lesson is talking about graphing calculators. So I have pulled up the internet because you can get a free graphing calculator on here, and you can figure out how to use a graphing calculator to do your homework on the internet without going and spending $100 on a graphing calculator. Save your mom and dad some money. You don't have to have one for the rest of this year. So don't go buy one just because we talked about it in this lesson. We only have like 6 lessons left. There's no point in getting one for this year. Algebra 2, possibly. But the majority of your homework can be done on a online graphing calculator. And if you have a smartphone, you can pull up a graphing calculator app on your phone. So don't spend a bunch of money on a graphing calculator, okay? You don't need it. So I like to use Algebra.org. It's a free graphing calculator, and I Google it and it comes up and I just click it. And then this is what you see. The whole screen comes up. And all you have to do is go in here to this field at the top. You've got your keyboard displayed. And you're going to look in your book, or you're going to look at the function that you solved for, and you're going to pull out the function. And in this case, our function is y equals 2 to the x. So we type that in, y equals 2, and we need to have a miscellaneous exponent. So we click this, and then we put x in for our exponent. That's what you would graph on your paper for your answer. You would just copy this green line onto your graph paper as best you could. Now you could zoom in, you can move this down, right? And you can see a little bit better where the y-intercept is on 1, and then you just make a little curve up. And you want to make sure that, you know, by the time you get to 6, you're at about the halfway point, and that's what you aim for. And then you want to make sure by the 4, you curve from 1 to the 4, you're back down on your line. So that's what you look for to make your graph. Where do I start rising? Where does it need to intercept the y-axis? And what is my angle here? What is my curve? You know, so by the 2, I need to be at the 1, right? 3 is about halfway. At the 4, I need to be at the 2. You know, by the 6, I'm about halfway. And then at the 8, you're at the 3. So you're just following your points on the graph, and you're making sure you make contact where you need to make contact so that your curve is as accurate as you can possibly do it. But you're just going to copy whatever the calculator says to copy onto your paper. You don't have to actually figure out the points yourself. Makes it so much easier. So we have another one, and the book gives us y, it's the inverse actually, y equals half with the exponent x. So in order to do that on here, you're going to say y equals, and half is a fraction 1 over 2, which is just 1 divided by 2, right? With the exponent, and I hit the parenthesis key so it knew that the exponent went to the outside of my fraction, not on my 2. So you hit the parenthesis, then you hit the exponent, and that exponent was x. So all you have to do now is, again, zoom in, right? You just really need to see the whole number. You don't need to see the half number. So we see the y-intercept is on the 1, okay? And it's just the reflection. Because this is the inverse of the whole number 2, it's going to be the reflection of 2. It's going to be on the opposite side, just like a mirror image. So again, the curve starts lifting off at about 4, and it hits the y-intercept at the 1. And then at the 2, it's on the -1. And then by the 4, it's on the -2. So you just curve it between that, and you keep the curve going at the same angle or rate of ascent. And that's it. You just copy it on your paper as close as possible to what you see on the screen. And that's the benefit of using a graphing calculator. And that is all we have for lesson 114. I would like to reiterate, you do not have to buy a graphing calculator. There are graphing calculator apps, or you can go to your web browser on your smartphone and just go to this link and pull it up on your internet and then type in what you need and use that as your graphing calculator. Don't make your parents go spend $100 on a graphing calculator for, the rest of the year. Just use the free stuff. It works. It is good enough. Okay? So that's all I have for lesson 114. I will see you in lesson 115.